The next discovery was developed by a scientist who actually worked with J.J. Thomson. His name was Ernest Rutherford. Rutherford did most of his experiments at McGill University in Montreal, and he's responsible for the discovery of a positively charged particle of the atom that's called a proton. Rutherford fired alpha particles at a very thin sheet of gold foil. Alpha particles are relatively massive particles, and they were traveling at such high speeds, so Rutherford and his colleagues expected the particles to be able to pass right through the gold foil. This hypothesis was based on J.J. Thomson's model of the atom, or the plum pudding model. J.J. Thomson predicted that the electrons were distributed throughout the atom, and that the rest of the atom would be a positively charged portion of the atom. Since the positive charge was distributed throughout the atom, they didn't think there would be much interference for the alpha particles. And so Rutherford and his colleagues believed the alpha particles would simply pass right through the atom, and they would be detected on a screen on the other side. This was not the case. To Rutherford's surprise, he found that some of the particles scattered, and some even deflected almost right backwards. J.J. Thomson's model of the atom had to be adjusted in order to fit the new evidence. Rutherford and his colleagues believed that there must be a very massive particle directly in the center of the atom, and this particle must be positively charged. They also believed that the electrons, rather than being embedded within the atom, were actually circling around the outside of this central particle, and so the atom was mostly empty space. Rutherford was given credit for these two discoveries. First, that the atom contained a dense center, which was positively charged, and had the proton. And secondly, that the atom was made up of mostly empty space. The next discovery resulted from the research of Niels Bohr. Bohr is responsible in large part for the transition to the modern view of the atom. And Bohr's model is actually called the Bohr model of the atom. Bohr found that electrons will actually travel around the atom in discrete energy levels. Bohr found that electrons can only exist on these energy levels. They can never exist between the energy levels. He also found that electrons can move up an energy level if they are given enough energy. He called this amount of energy a quantum of energy. A quantum of energy was just a very small amount of energy that was the exact amount of energy for an electron to move from one energy level to the next energy level. The next discovery was from Louis de Broglie. De Broglie proposed that waves can act like particles, and particles can act like waves. De Broglie suggested that electrons are better described as waves, rather than as particles. This was significant because we can describe the energy of an electron better by looking at its wavelength, rather than just its mass and velocity. De Broglie paved the way for other scientists to expand on his idea of describing the electrons as waves. Werner Heisenberg proposed that one of the implications of electrons behaving like waves is that you cannot know both the speed and position of an electron at the same time. This is called the Heisenberg uncertainty principle. Erwin Schrödinger developed a mathematical equation to show where electrons are located around the central nucleus of an atom. Since electrons behave like waves, and we cannot know precisely where they are located like Heisenberg has told us, we cannot pinpoint the electrons to specific rings like in the Bohr model. Schrödinger showed us with his wave equation that we can only know regions of probability of finding an electron. And we call this the electron cloud model. Finally, there was James Chadwick. Chadwick was responsible for the discovery of the neutron. We now know that the neutrons are located in the nucleus of the atom, along with the protons. And thanks to the work of the other scientists, we know the electrons are found around the nucleus in an electron cloud. And that's the atom.